Recursion, generally, is when a function calls itself. The main idea behind this is that a problem can be solved with the same logic and by splitting the problem into smaller bits. Recursion is used a lot with searching and sorting algorithms. Sometimes we can implement something as a simple loop, or as a recursive function with relative ease. However, sometimes a recursive function makes for the simplest implementation. When creating a function that will call itself, we need to make sure to include a base case, otherwise known as a stopping case, so that the function does not loop forever. But if that base case is not hit, we will do the process over again and call the function with new parameters. A recursive function can be void, or it can return a value. It can take some work to think in terms of recursion instead of iteration. Build your function a step at a time and test after each addition. Let's step through the execution of this function, which generates a factorial. We initially call the function from outside, such as from main or something, and we're passing in the argument of 5. Well, looking at the function, the number isn't 0, so we're going to multiply 5 by the result of factorial of 4. And again, 4 is not equal to 0, so we're going to multiply 4 by the factorial of 3, and return that value back to the previous caller. And so on until we do finally get to 0. Once we've called the factorial function with an argument of 0, when we get the number 0, we return the number 1. So now our recursive functions start returning back upwards. The number 1 is returned to the 5th function call, and it's multiplied by the value that it had, which is 1. 1 times 1 is returned to the 4th function call, and it's multiplied by 2. And so on until we reach the topmost level, the very first function call, and everything ends up being multiplied together and returned back to main. That was a simple example, but as functions that use recursion get more complex, it might still help to step through and write down the variable values at each step. So, where does recursion really come in handy? Dealing with data, building data structures, doing searching, and doing sorting. Here are some practice problems to work on.